Hey guys, welcome back to Digital Learning, Etowah style. Today's learning target is identify a variable degree and or its location so we can determine if an equation is linear, quadratic, or exponential. So if you remember, when we talked about a degree, it was talking about what is the number of the highest exponent attached to a variable. So we're going to be looking at the numbers attached to our variables, or sometimes it matters where the variable is located. And so that's what we're going to be going over today. And that tells us whether the equation we're interested in is linear, quadratic, or exponential. So I have a little summary for you here. A linear equation has a x with an exponent of 1, meaning the degree is 1 because the highest exponent is 1. So I've given you several examples here. 5x plus 1, there's really a 1 right there. It's an understood one. We don't print those in usually. That's the highest exponent on a variable, so that makes it linear. Y equals 1/2 x. There's a 1 sitting right there, linear. Here's a line in standard form. We haven't solved for x like these guys are in slope-intercept form. 2x plus 3y, our x is to the first, so it is still linear. Our quadratic has a degree of 2, meaning the highest exponent is 2. So when we look at all of these equations, there's an exponent of 1 here on this x. However, the highest exponent is this 2. That makes it quadratic. This is the only variable and its exponent is 2, so it's quadratic. There is more than one variable, but we're looking at the x and the x is squared. This is quadratic. All right, and then our final one, exponential. Exponential, we're not looking at the degree with it, but where is the variable located? So the variable should be located in the exponent if it's exponential. I like to say the x is in the exponent for exponential. So when we look at our equation, the x is in the exponent position. That makes it exponential. Equation number 2, the x has been raised to this exponent spot, exponential. And equation number 3, our x is up here in the exponent, exponential. So what you're going to want to do as you look at each of these equations is ask yourself, is the highest degree 1, 2, or is it located in the exponent? And that helps you answer whether the equation is linear, quadratic, or exponential. So here's some examples. Let's give them a try. So our first one, y equals 6 raised to the x plus 3. The x is in the exponent. That makes it exponential. Okay. All right. So let's take a look at the second one. Y equals 7x squared plus 5x minus 2. So we have an x to the first. That might make you think linear, but actually the biggest one is x squared. So that's going to make it quadratic. In number 3, we have 9x plus 3 equals y. Look at your x. Has a 1. There is not another x. This is x to the first, and x to the first makes it linear according to our notes. All right, let's take a look at D. Right now, try pausing the video and seeing if you can get the next 3 on your own, and then come back and check to see how you did. Okay, we have 4 raised to the 2x equals 8. The x is in the exponent of the 4. It makes it exponential. In E, negative 3x squared plus 2x minus 9. This 2x has an x to the first, but that is not the largest exponent on the variable. This 2 is. And anything with an x squared as the highest exponent, that makes it a quadratic. And for our last example, negative 1/2 x minus 9. This x has an understood 1 right there. The highest exponent on the x is a 1. That makes it linear. All right, so you have an assignment on Canvas to complete using these notes. Make sure you refer back to them to help you, and email if you have any questions. Bye.